Hello and welcome back. In the last VGA video I turned the output circuit into a PCB, and in this video I'd like to turn the pallet circuitry into a PCB, and that will give me a very low level of breadboards involved with the overall system, which I'm quite looking forward to. So let's have a look at this circuitry as it currently stands, and then we'll get looking at the design. Okay, so here's the VGA circuit. Now at the end of the last video I had the output circuit plugged into a couple of fragments of breadboard and a miniature connector I made, and now I've made a little backplane interconnect. If you look in the description or in the corner there will be a link to the video where I made that. Since the end of that video I've also tidied up some of the wires here just by switching longer ones out for short ones. So let's try and extract this. The address, don't need that anymore. I should switch the power off. It's the color index input. It's the right line and the clock. It's memory data. Right, that was just an extra ground tie I had. And then obviously here we have the actual red, green and blue components of the pallet. And a power line. Now you can see just how big a reduction in space the system taking up it's going to be when I've got the pallet PCB on here. Obviously the remaining circuitry we want for the sprites is going to fit in some of these gaps. Okay, removing all of this from the build is actually a little bit scary because obviously the circuit's very broken. So we're going to need that PCB. Let's take a look at the design. Okay, so here's the pallet circuit as we left it at the end of video 11. Now, what I haven't done is the changes we did in video 12. And that relates to these unused address lines. I just created a temporary register that I set those from, created a kind of hacky way of setting the contents of that register, and then we messed around with that. And I think that's a very low cost additional thing to add to this build. So let's make use of that memory. Basically comes down to the fact that we would ideally have 256 byte memory chips here, but these things are 8 kilobytes, so may as well use the extra data. Right, now we need to store that register somewhere. And I think it'd be good to have some LEDs for these values. People keep complaining I don't have enough LEDs on the VGA boards. Right, so these colours are the output, the 8 bits of VGA data input. Of course, we don't need all 8 of those to come here, but it seems logical to do that. These are generated signals. We've got the clock coming in already. We do need those memory lines. Now the pallet is 256 entries, and each one fills 4 bytes even though we only use 3, so that's 10 address bits we need. Okay, we'll need a header for these, I need a header for these. So we need a load line for this register, and so what we did in, I think it was video 12, is we just made it so any write to the 4th byte of a pallet entry would load that register, because that's the unused 4th line here, and it makes it very easy. Right, so I need a header for that. I'm going to use a 12-pin one. Right, is there anything else we need? hadn't actually connected. The unused outputs here we need to flag. That's interesting, we don't actually have a VGA clock signal used here at all. Now the reason for that is we latch the inputs on the outside of the preceding circuit, and then the output circuit latches its inputs. Right, so the pallet we're going to stick next to the output circuit. I want to match these inputs just because it's going to make routing the wires a lot easier. So ideally we want to fit inside that height. We at least know we're going to make the backplane easy to route there. Now putting these right next to the outputs is actually what we did on the breadboards, and the flow of that kind of seems odd because these are actually driving inputs to the RAM chip data lines, but of course the RAM chip data lines have to be connected to these outputs as well. Not making it easy to fit anything in here. On tile data, the address bus is down the side here. Do like the idea of having it here though. Data's on the side. Do want that the other way around. Put 0 in the identifying pad here. I think I will ditch that VGA clock line. I would rather that be at the bottom. Not easy to do that. I'll put an extra ground pin in here. I need to swap those over if I can. Now, did that do what I wanted it to do? It can be slightly annoying to route, but far from the worst job here. Okay, as an approximate layout, I think we're doing okay there. These ones are just for stability, but it's going to be okay. Now I'm going to do the regular thing and make sure I add this to the backplane now. Now this will look weird because I'm deleting and then replacing with an identical part. The one I'm bringing in is from the backplane schematic. Now all you need to do is route it. Now, whatever I do here, I've got to replicate 3 times. Okay, that's not right. I had just enough lines in the wrong place to make it look like that other one was the red memory. That's better. I am thinking of reordering these though. Now the ordering of the data lines is entirely arbitrary because any change on the output is matched on the input. So I think R3 would be good if it was actually R0. Good, 0, 1, 2. Now I've got the VGA data lines to get up here. Now the ordering I did here, I can do for green and blue as well. Let's do that now. I've got to cross-connect these with the data lines over there at some point. The whole replication of the circuitry between red, green and blue, it's obviously only going to work if I have some kind of symmetry in the wiring. Pretty good. Right, that's a lot of lines done. Okay, that feels pretty good. I'm wondering if those should be the other way around. Now the tricky bit here is 8 address lines. Let's see if I can use a similar configuration to that. Alright, it's free. Thinking these would be better off swapped around. Kind of feels like those would have been better off the other way. End up doing a lot of this. See if I can reorder those a bit better. Right, so 0 if I bring that here and then 1 here, so 0 is where 3 was, 1 was where 4 was. We go 3, 2 where 0 was, 3 where 1 was. And then we do the same pattern up here. Right, so index 0. Now this is 8 independent circuits, so as long as I keep the right lines with the correct ones, I can swap these around as much as I want. And hopefully this has just made my routing easier. Looks like it might have done. Those would be better the other way around. Doesn't feel like there's very many lines left, but some of these are going to be difficult. So just power and ground. Now most of these boards I've been making 4 layers and this will be no exception. So power and ground are going to be a lot easier than they might otherwise be. Right, I think that's everything. I always wait till the last minute to set the internal planes up, just because it does make the whole thing a bit more sluggish. Right, how are we going to add this 4th line? Don't need to change over here. And we're going to need to stick a standalone resistor in. And okay, I'm going to want to swap these over just to make the routing a bit more sensible. Okay, now that's everything we need. Fairly straightforward change. And I just noticed I wasn't recording properly. Now, this change was actually a lot easier than I expected it to be. I brought the extra line across. I've moved these LEDs down. I also swapped the resistors onto the other side, just to make the routing slightly easier. But the change was fairly straightforward. And I've added the internal ground and power planes and the fills. So I just need to finish labeling this up. Let's take a quick look at that. The yellow line there is just missing. Need to check the symbol on that. It's a nice looking board though. Okay, something's not quite right with the runtime DRC checking. Something moved. think that just needs a copper area rebuild. Feels like there's something else in there. Ah, I see. And finally, we've got a PCB with no DRC errors. I get very nervous with boards like this where I've made several mistakes along the way though. Let's get it ordered. It's going to look pretty good. So same as on the output circuit, they have turned this round. Made up a new board for aligning these. That stuff in the top left is weirdly messy. Most of it's okay though. Oh, a bit smudged, but I think it'll be okay. Had a bit of pain with these resistor arrays in the last PCB. Okay, top of that's got slightly less solder than it should have, but I think there's more than enough there. Alright, so the 138 is a demultiplexer chip, and we use that for deciding which of the free memory chips we need to write to. ACT 157s are used to select between the address on the address bus for a memory write and the colour index data for the memory read. I have had people ask me why I use ACT for this, and that's because they're faster and able to handle the video speed. And so the next obvious question is why I don't use ACT for everything. And one of the reasons for that is they are less well behaved. They tend to put a bit more noise onto the power rails. So the 574 is the D-type latch register. Okay, it's a little bit of a low solder amount there, but I think it's enough though. Then these 541s push memory data onto the output lines when we're doing a write. Need to watch that one very closely in the reflow. It's difficult to tell with the smudge if it's positioned well or not. Right, I think that's everything, so let's get the hot plate out and reflow it. Okay, first impression is good. Okay, that one there I was worried about. Looks like it's got good solder on it. I was slightly worried about the alignment on these ones, but that kind of looks alright. Similar problem on these memory chips actually, because the pins go underneath. It's very difficult to see if they're right. There was one pin there I didn't like the look of. Similar there. LEDs are good. That 1K looks okay. And that looks like a solder bridge to me. Both sides. Put a little bit of flux on here. I think that's okay. Alright, there is nothing really to be wrong on the back of this PCB. We didn't solder anything. I should get into the habit of checking it. Let's test it. Okay, well if everything's right, this should be a fairly easy job to fit it. I was a little bit uncomfortable with that, so I'm going to ease it back out and check the pins. Right, there's no bent pins, so the first time you plug it in, sometimes you've just got to correct for some slight leaning, and then it usually goes in very easily. Fabulous. I'm going to hold my breath and power it up. Well, that certainly looks promising. Fabulous. Oh, I'm so pleased with that. Right, before I move on, I do just want to test for LUT index control. So I did put that on some LEDs. Okay, that LED is a lot dimmer. I'm wondering if I've got the right value of resistor on there. I'll do a bit of little research on that and maybe come back to it in an extras channel video. Fabulous. I am very pleased with that. After the previous VGA video on the output PCB, where I had to do a whole bunch of troubleshooting to get it working, including the 3 bodge wires that I'm going to have to replace at some point, this one just worked first time. I just need to double check one of the resistor values because the LED looked a little bit dim. Going to have to leave it there though. The bars test is a good stress test of the pallet output circuit, but now I've got all of those breadboards converted into PCB. I think I'm going to be able to explore a few interesting demos and then hopefully quite soon move on to the next parts of the VGA, which is going to be the sprite circuitry. As always, a big thank you to all my patrons. I appreciate the support and I hope everyone found this interesting, and I'll see you again soon. Goodbye.